Hello students, so we have come up with our next video, and this video is about vector treatment of Coulomb's law. So last time we saw that Coulomb's law is the law for electric force between 2-point charges, which is given as F equals to K Q1 Q2 upon R square, where Q1 and Q2 are the magnitudes of the charges while R is the distance between the charges. Now you can also write this as 1 upon 4 pi epsilon naught Q1 Q2 upon R square. These are the two variants of Coulomb's force in vacuum. When it comes to a medium, you have to write this force as 1 upon 4 pi epsilon Q1 Q2 upon R square, or you can write 1 upon 4 pi epsilon naught epsilon R Q1 Q2 upon R square. Now all of these variants we saw in the last video. Now today we'll see the vector treatment of the force. We know that electric force is a vector quantity. Any force is a vector quantity, by the way. So when it's a vector quantity, it has a direction associated with it, and a vector can be written as vector equals to magnitude of the vector into unit vector. Okay, so any vector can be represented as vector equals to magnitude and magnitude times unit vector. So here when we write force, we'll put an arrow because we generally put an arrow for a vector quantity. So force in vector form can be written as force and arrow over it is equal to 1 upon 4 pi epsilon naught. For the moment we are writing it for the vacuum. So F vector equals to 1 upon 4 pi epsilon naught Q1 Q2 upon R square, and here we write R cap, where R cap is the unit vector and R cap determines the direction of the force. Okay, by the way, your Coulomb force or electric force is a kind of central force. Okay, let's understand what it means. Your electric force is a central force. Let's understand what it means. Whenever any force acts along the line joining the two particles, suppose this is first particle, suppose the name is Q1, suppose this is another particle, and let's say Q2. When the force acts between them, acts along the line joining them. So this is the line joining them. Okay, if the force acts along this line, we call such forces central force. So those forces which act along the line joining the charges or the objects, we call them central force. And the electric force also acts along the line joining the centers of the objects. Okay, so electric force is a central force. Now when there are two charged particles, the force on Q1 because of Q2 can be written as F12. So it means force on Q1 because of Q2, or force on first because of the second, and force on Q2 because of Q1 can be written as force on Q2 because of Q1 can be written as F21. Force on second because of the first. Force on second because of the first. Okay. So suppose you are finding out force on first particle because of the second, you will write F12. And then the force formula will have a form F12 vector is equal to 1 upon 4 pi epsilon naught q1 q2 upon r12 square, and here r12 cap. Okay, and if it is 1 means if it is the force on second because of the force, then you will write F21 is equal to 1 upon 4 pi epsilon naught q1 q2 upon r21 square r21 cap. Okay, and now we know this thing